everybody. Thank you very much for joining us today for another fantastic Nose 2020 extended session. I am joined by my co-host Chris Scarden, who is a field engineer at Neo4j and is the maintainer of the .NET driver. So, Chris, want to tell us a little bit about yourself, a little bit about the driver, a little about your involvement with Neo4j?
Well, I've been using Neo now for 7-8 years. I've been part of working with Neo for, I guess, the last 3 or so now. I'm not sure. It's been a time. And yeah, I maintain and manage the community driver for the .NET side of things. Other than that, I'm pretty much a standard .NET developer who happens to do graph databases.
Excellent. Thank you. So very quickly, for those of you who are new, this is your first Nose 2020 extended session. So we've got a fabulous talk lined up for you. So we're going to be handing over to Michael shortly. And what we're going to be doing at the end of Michael's talk, we are going to go into a panel discussion. So if you've got any questions about the talk or anything around that, drop your questions in the chat. We're keeping an eye on those and we will pass them on as part of the conversation. Then apart from that, sit back, enjoy the talk. I'll be handing over to Michael Herman, who's a solution architect and developer, and he's going to be telling us about Csharp Superstack. Michael, over to you.
Thank you very much. Good morning, good afternoon, good evening to everybody. It's really a privilege to be able to talk about some of the work that I've been doing with Neo4j and .NET this morning. So it's called the Csharp Superstack, and it's a way of building highly scalable Neo4j web applications using C#, HTML, CSS, and without having to use JavaScript. And that's going to appeal to some segment, I think, of the people that are watching and people that want to make greater use of Neo4j, but maybe aren't familiar with some of the other development platforms that are out there. So I'm a solution architect and developer. I live in Alberta, Canada, about 3 hours east of Calgary. I live on a ranch. These actually are my cows and calves from last year. That's what it looks like out here, except we have about 2 feet of snow right now, and it's -11 Celsius this morning. I've got about 4 years of hands-on Neo4j solution development experience, going back to, October 2016. I've written quite a few articles about how I've used Neo4j, and I kind of coined this term graphatization, the graphatization of various kinds of data sets. And so if you go to hyperonomy.com and search for Neo4j, you'll find a list here. So my singular goal for the Csharp Superstack and for today's presentation is making Neo4j web application development easier for C# and .NET developers. And hopefully I achieve that goal in the next hour or so. So what we're going to talk about, I'm going to introduce the BLAZOR web application framework. This is an open source project sponsored by Microsoft that makes it a lot easier, at least for me, as a C# developer, to build high-performant, high-quality web applications without having to use JavaScript or any of those multitude of JavaScript libraries, etc., that are out there. For those that are newer to the Neo4j platform, I've got just a few slides on the graph database server, and then as Chris alluded to, I'm going to talk a little bit about the work, I guess, that he's done on the Neo4j.NET integration, how the driver works a little bit. And then we'll look at how all this comes together to create the Csharp Superstack. I do have a fair number of slides, but I also have 3 demonstrations of live code that I'm going to show you as well. So the Csharp Superstack is based, again, on the BLAZOR open source project, and it's, from a Microsoft perspective, is called a feature, a part of ASP.NET Core, which is also an open source project. The Csharp Superstack that I'm talking about is built on the BLAZOR server app hosting model. There's another hosting model called the BLAZOR WebAssembly app model. I'll describe that briefly, but I'm really just focused in on the BLAZOR server. So the solution stack is just plain old C#, HTML, CSS. Optionally, you can call into JavaScript if you need JavaScript to access, some of the DOM functionalities or DOM APIs. And then, of course, CYPHER and Neo4j. So if I was to try to describe in a concise, few words what BLAZOR is, it's a reusable web UI component programming model. And probably each of those words is important here, and we'll discuss those as we go through. I found it to be powerful and uncomplicated to use. But if you need to, again, go deeper into the browser and its capabilities, JavaScript interop is supported. The two hosting models, BLAZOR WebAssembly, for apps that run entirely in the browser using the WebAssembly or WASM virtual machine that's available in most browsers today. And the one that we're focusing on is BLAZOR server apps, applications that run, the executable code runs entirely on the server and then projects down a traditional HTML web user interface into your browser. And we'll go into more details as we move through this. And so BLAZOR, both BLAZOR server and BLAZOR WebAssembly is now quality production release as part of both .NET 3 and the recent announcement of .NET 5. So it's something you can go out and use today. So the BLAZOR stack, of course, we start with plain old HTML and CSS. You have the ability to code, or if you want to call it scripting, directly within your HTML pages, your HTML Razor pages using C#. You code against something called the BLAZOR component model. These are the reusable pieces of web UI that you can use to compose more sophisticated Razor pages. And then the Razor pages go through a process where they're compiled into an intermediate representation that's compiled into C#, and that's used to create .NET assemblies. And there's a lot of magic. There's actually a lot more going on in this box than I'm going to describe right now. But the whole idea that is whenever BLAZOR is running on the server, it's obviously running, .NET MSIL, but it's also running the .NET assemblies directly in the BLAZOR WebAssembly model, where the application is running entirely in the browser. Your .NET assemblies are actually downloaded and executed in the browser. So in terms of hosting models, there's the .NET Server Runtime based on ASP.NET Core, or like I said before, you can host applications directly in the browser. The component model is designed so that almost everything you create in terms of user interface and the C# logic that you incorporate in them can, with a little bit of care, can run in both environments. And then, of course, in the bottom right, you have image files that might be part of your application, and then optionally you can include JavaScript as part of your project. So just one slide on WebAssembly. So the top 4 bullets here, these are the same both for WebAssembly and for the server hosting models. So again, reusable, retargetable web UI component programming model based on C#, HTML, and CSS with Java interop. You have the full C# .NET runtime stack. It's actually running the mono .NET runtime environment in the browser. That's the only part of the code that's actually compiled into WebAssembly mono.wasm. And you can use any C# development platform, Visual Studio, Visual Code, or whatever you choose to use there. The WASM apps are deployed into and actually run in the browser. And interchangeably, people refer to BLAZOR WASM and BLAZOR client side to talk to that, to refer to that hosting model. Again, all of your assemblies, both for your app and the .NET runtime, are downloaded and executed directly in the browser. And I think apart from this slide, this is not the focus really of this webcast. What we're talking about is BLAZOR server apps. These use a traditional server-based web application hosting model, like an ASP.NET application. The web UI is defined server-side, but then projected down into the browser. The UI is represented on the server and in the browser using a highly compressed, efficient sort of display list bytecode. And I'll talk about, I have some slides later on. I've actually hidden them for now for time, but the idea that even though this is running server side, it's very efficient in terms of the interactions between your user interface running in the browser and your application running on the server. There is a single signal R socket connection that's maintained between your application running in the browser and your application running back on the server. It's a highly efficient, optimized bytecode that is sent back and forth just to exchange the minimum updates that are required to update your user interface. And because this doesn't have any dependencies, for example, on the WebAssembly virtual machine, BLAZOR server apps can run in any browser. They're plain old HTML. This is a slide that you could look at after the talk. You could pause the webcast and have a look at it. This is probably the most detailed architectural comparison I could find from the people at itvisions.de. So at the top, we have a traditional ASP.NET Core application. In the middle, we have the BLAZOR server, and at the bottom, we have a BLAZOR WebAssembly application. And if we look here at the BLAZOR server, there's the orange colored box, the shadow DOM. This is also referred to more formally as the render tree. And this is what is being maintained on the server, a representation of the entire user interface that's running in the browser. And as you interact with your browser-based user interface, there's a little JavaScript stub there that is sending messages back to that render tree, to that shadow DOM, and that's interacting with your C# code on the server. With WASM, that shadow DOM is actually downloaded and maintained in the browser, because that's entirely where your application's running. You're only calling back to the server when you need data or some access to some external services. So let's go to a demo, just showing you how a simple BLAZOR server application is created. It's exactly the same as for a WASM application as well. So if we go, I've got Visual Studio 2019 open. So let's go and create a new project. Oops, let me go back. So if you type BLAZOR, and you have to have a fairly recent version of Visual Studio 2019 because you want the BLAZOR app template. And this template is the same template you'd use to start off both server apps and WASM apps. So, you know, click it here, click it here. So we'll just create a little sample app. And this is just so you can see that it's how it's done once and that it's pretty straightforward to use. So here's where you get the choice of the hosting models, the app model, server model, or the WebAssembly model. There's some other parameters here that can be used to configure your app. And it'll go through, create the project, create some sample pages, some sample components, and we'll look at that here in just a second. I ran these this morning, hopefully, so they wouldn't be too slow warming up. There we go. Okay, so close that. Let's just go interface you choose is entirely up to you. Bar down the left-hand side. That's interesting. Probably clicked on that a little too quickly. On page. Some basic HTML at the top where we define the counter. The page directive at the top is for, there's a button here, and the onClick event is going to be Csharp method down here at the bottom. So you have the option of putting your in a code behind. So what's going to happen is every time we refreshed, as we see in the user interface. So that should be up by now. And so if we go to that counter page, see it's very efficient. The whole page is not bad. While we're here, let's look at a local web service that simulates some weather information. And we'll have a quick look at how that works. And we're going to build on that. We're going to add another tab here that will go and fetch some of the movie data from a Neo4j database. And then in the third demo, we'll look at how to make that more interactive, the ability to edit, delete, and add new items to the movies database. So this is a good starting point. And if we look at the page to fetch the temperature data, again, just a little bit of HTML here, defining a traditional table in the traditional way, some headings, and then down here, wherever you have the @ sign, that's the way that you embed some C# code into your HTML. So there's the for each, where we're enumerating over a list of forecast information, and from there we're pulling out the different temperatures. And at the bottom here on initialize async method, we're getting the forecast by calling this service. So this is a traditional pattern. If we just quickly look at that service, you can see it's just get forecast async and of that weather information. So the patterns, very easy to understand, and in hindsight, very easy to extend into Neo4j. of that thing. Okay, so most people are probably familiar with the Neo4j platform. I won't dwell too much here. So we're looking at how do we easily build .NET C# applications that run against the Neo4j database. This is some examples that you'd find in those articles on hyperonomy.com. This is a visualization actually of a large data center environment. Visualization of a web application. This is a visualization of a small .NET Web Forms application, a little veterinary booking application out of one of the entity framework manuals. This big thing on the right here, that's what the entity framework looks like when you call into it, just as an example. So I'm going to assume people are fairly familiar with the CYPHER language. Here's a particular model. We can have a query here that finds friends of friends in that model, strictly friends of friends, and give you an idea of what the query language looks like. And here we're interested in the person Joe and who their friends of friends are. So here's Joe. So the only friends of friends is Anna, and that would be returned. So the .NET Server protocol is a lead into the discussion around the driver. You send those CYPHER commands that has the ability to encapsulate those CYPHER commands, send them to the server, and then you get information about the entities that match the criteria in your statement. It's the same kind of protocol for adding things to your graph data model, database model, deleting things, etc. So when we look at how that's integrated into .NET, some of the work that Chris has done, here's a very simple kind of hello world type example that shows how you use the driver. You connect over the Neo4j Bolt protocol. You provide an authentication token. You get a session off of that driver instance. And then the easiest way to run a simple command is to just simply run it off the session object. You get an array of objects called inodes back, and then you can enumerate over each of those inodes or each of those records that come back and pull out different attributes or different parts of the metadata that are associated with that object. Here's an example of a simple console app that goes against the movies database. It's very similar to what we saw before. So I've got something called get records. When we get the records, we're going to dump out the ID, the unique identifier that each of the Neo4j records has. And down here, we just do a match on objects or entities that have a label of movie, and we're going to return them ordered by the title of the movie, and return that as a list of these inodes. Again, an inode just has the ID for the entity. It has a list of the labels for the entity, and then it has a dictionary of the metadata values. And so when you see an entity being presented in the Neo4j browser, that's all the information it's operating on. And here's the kind of results that come out for the standard movie database. There's like 38 movies there. The standard query methods, there's a couple of different ways. I kind of using the lowest kind of common denominator API within the driver. It's interesting to note that internally, and these are actually the text from some of the implementation of the Neo4j .NET driver on GitHub, that internally it relies heavily on dictionaries. And so that was a key to me to say, well, I'm going to use, in this wrapper that I'm going to put around the driver, I'm going to be very dictionary centric in that approach. So that brings us to the actual C-sharp Superstack and its implementation. So here's the diagram, the architecture diagram that we had before. And we're going to look at this project called BLAZOR server app movies 4. This you'll find on my GitHub repository, github.com/MWHerman2000. And so if we start with that basic model, if we have our BLAZOR application, like the one that we saw in the earlier demo, and it's running on the .NET Server runtime in the server hosting model. I've created this wrapper, which separates you from having to understand or know anything about the CYPHER query language, and allows you to pass in your metadata properties, your values using dictionaries, and it's just kind of a little more .NET-ish approach to the driver itself. And so what that wrapper does is makes it easier for your BLAZOR application to talk to the driver. So there's kind of two pieces within that area. There's the BLAZOR component code that runs in that @code directive in your web page, little stub there, primarily to drive the UI. And then there's what I call the Neo4j movie service, equivalent to that temperature forecasting service that we saw before, that then runs on the server, and it's the one that actually calls into the wrapper, which in turn calls directly into the .NET driver, which in turn talks to the Neo4j server where the movies is being hosted. So in terms of those methods that are actually running in the BLAZOR component, in the UI component, there's just a few here. There's a little pop-up dialog, and so you can use that either to add a movie or use it to delete a movie, or edit a movie, and that includes deleting a movie. And then when you click save or delete or whatever the method is on that pop-up, there's three methods that are defined within the BLAZOR component. One for getting all of the movies, for showing you a tabular listing of all the movies that are in the database, being able to save any updates that you've made, either when you're creating a new movie or editing an existing one, and then if you click delete, there's a delete movie update. So fairly simple set of methods to implement. Those bottom three methods in turn call into the service. There's get movies async, merge movie async, and delete movie async. And merge movie handles both the cases where it's creating a new object, a new movie, as well as updating an existing one. In the wrapper, I've defined a few methods: query, create, and update, and delete. So basically your CRUD type operators that you'd expect against in most database applications. Okay, so let's go look at doing pretty good in terms of time. So I'm going to go in two steps here. This this app, which is called BLAZOR App 3S, not very creative, but this is an example of a simple, kind of the simplest BLAZOR application that simply retrieves the movies from the database and displays them in a table. Let's run that and hope it doesn't take too long to come up. I do have Neo So if we look at, it's just a table. It has the ID, the label, the title, the metadata that's associated with the movie. And we simply iterate over the each movie that's in the movie's check. Turns out that there's one movie that doesn't have a tagline. It's actually undefined, and when it comes back from the .NET driver, it actually doesn't exist. So the first time there's no tagline properly. So I had to add this conditional statement. It's an example of the coding you can do directly within your HTML page. So is one of the simply have and that will be, when the page is refreshed, they'll be displayed. So we should be able to see that now. Yeah. So you'll see there's a whole bunch of things actually in here. I've kind of elaborated on the original the original weather forecast example. I wanted to fool around with downloading CSV data, talk about movies, and so to label the. So we'll just service. So if we go over here, where this is just an unsophisticated way of getting the data. Like I showed you in the console examples. Again, we get a handle to the driver. It's just the Neo for the movies database using movies as the password. I get a handle to the session, and then I run an async task to execute a read transaction where I run the following CYPHER query to get all of the movies returned. The returned is inodes. I convert those to array, and that's what I'm returning from here. So again, very simple. Simple technologies. If you're a C# developer, it's just simple technologies for you to use and become familiar with. So we don't need that one anymore. And now we'll look at something a little more sophisticated. I didn't think I changed that, but I did. Let's see. Let's run this one, I guess, so we can get an idea of what we're talking about. Okay, I guess we're still waiting for that to come up. Hopefully I don't have a breakpoint set somewhere. So what I did is I took that simple HTML table we had before, and I've added an edit button. And there's the edit movie show method that's called there. And down at the bottom, underneath the table, I've added a pop-up dialog. That pop-up dialog allows you to edit the title and the release and the tagline. You have the ability to save that. If this is not a brand new, if this is an existing movie, you have the ability to delete it as well. So we call the delete movie update method. And They're just down here at the bottom like we saw before. So on initialize, we get movies just like we did before. When we want to add a new movie, we set a dummy movie to be the target movie and call the pop-up. Pop-up inspects that target movie object. When we want to edit an existing object, we are past that object from the HTML user interface, and so that changes the target movie. Again, we show the pop-up. When we click save and we click delete, it's a simple matter of calling into the movie service to save that object. If the ID is empty or null, it's assumed to be a new object and it's added to the database. And then we refresh the movies. If we want to delete a movie, we just send that target movie object to our service, and that goes fairly straightforwardly. And I have no idea why it's taking this long. Always demo mode. Okay, so if we look just briefly at we've been looking at the pages. If we look briefly at what the service looks like, it's already open here. Get movies async. So this is calling into the wrapper, and it's just and there's a couple of different versions of query. This is just saying we want all the objects that have a label of type movie. If we want to merge, we check to see if the ID is null or empty, and then we call create. And so here's an example. We're passing in the label, and then we pass in that dictionary of metadata that I talked about before. And then finally, delete movie just calls delete movie. So this is the BLAZOR side of the equation. And then when we go and, for example, look in the entities class, the helper class that this is running into, we can see a bunch of different methods here. So this is an example of update. I'm doing a little bit of argument checking. I'm building up the CYPHER string and then executing that CYPHER string down here at the bottom. Well, that's very disappointing. Just going to try that once more so that you know that it works. Just give it a couple seconds here. I've got a couple slides to finish up with, and then we'll be able to go to questions. Okay, well, let's go finish up some slides and we'll come back. I literally worked on this non-stop yesterday, and without any issues. It's always the way that when you get online, it's different. Yeah, so just some final notes. Scalability is always a big discussion or question. Kind of a rule of thumb is you could support 200 2,500 connected BLAZOR clients. This is a BLAZOR server client browsers. And you'd need about 1.5 gigabytes of memory. Again, there's a small, highly efficient SignalR connection that's maintained between any BLAZOR server app running in the browser and the server itself. Here's some, I don't know if these are independent sources of data, but the ASP.NET Core team has done some performance testing. About 250 kilobytes of memory per client. They found that on Azure, that on a small virtual machine, they can easily support 5,000 clients, concurrently active clients with no degradation. On a large machine, as many as 20,000 clients. And the main factors controlling performance are memory and garbage collection. Here's a list of resources. Tried to keep this relatively concise. The top one redirects you to the Microsoft MSDN pages for BLAZOR. There's the open source project itself. There's the formal documentation. This is actually an interesting example when you want to combine the BLAZOR component model with existing MVC apps. There's quite a good free BLAZOR ebook published by Microsoft to have a look at. Of course, there's the developer resources for .NET on Neo4j. And there's some really good programming examples that you'll find on these pages as well. Lastly, all of the code that I showed and the presentation itself can be found up on my C# Superstack project on GitHub. There's also just a large README file on GitHub that has links to many, many more resources related to BLAZOR. BLAZOR has been like an experimental project and then kind of this intermediate project, and now it's formally released. It's been around for quite a few years. I think dating back to maybe it's been around for 2018, maybe 2016. Avoid any of the older BLAZOR resources. There's a lot of YouTube videos, a lot of old YouTube videos on BLAZOR. Anything that's older than COVID year 2020, I would try to avoid those and stick with some of the examples that I have here. So we'll go to questions. Just before we toggle into questions, let's just see that app running. Yeah, there it is. So if we want to go in and let's say edit existing one, the matrix 2, just keep it simple, click save. We can go in here and edit this one and delete it. Anyway, I wasn't expecting that either. So anyway, let's leave it with questions, and I'll fix that up and republish that up to publish that back up to GitHub for you.
Cool. Thank you very much. Thank you very much, Michael. That was brilliant. So I think we can see you, and I think we've fixed the audio. So hopefully we're in business. Those of you watching, if the audio goes a bit funny, let me know. We'll try and fix the technical things around that. But anyway, super exciting. Thank you very much for that, Michael. That was really good. And I guess we'll start doing some questions. I'll hand over to Chris, because Chris is the .NET developer. So.
Okay, so how have you found, in terms of using the driver, one aspect which is not you didn't go over, and I imagine you've done it plenty of times, is things like IOC and DI from the point of view of the driver. How are you managing it in your applications? How are you managing things like IOC and dependency injection in the applications? Are you having a single instance of a driver? How are you using the sessions around?
Oh,
that side of
okay. Yeah, because dependency injection I alluded to in one of the slides, and there's a BLAZOR discussion around that. I'm creating a single instance of the driver. That'd be a single instance that I maintain in the service. So every time you make a call, it checks to see if that instance of the driver's been instantiated. If it is, then I just reuse the one that I had before.
So in BLAZOR, is that as a per session? So per person who's on the server gets an instance of the driver?
I believe so. I'd actually have to confirm that. It wouldn't have to be, because that service. The service right now is probably instantiated for every session, but it wouldn't have to be for sure.
Oh, so you could, I see, yeah, because you'd separate your service out to another. You'd be calling something else other than, normally it wouldn't be hosted inside the BLAZOR app.
Right. And it's not too far from being able to do that. It could be a web API, for example.
How are you finding using the actual inodes for doing stuff with? Because obviously one of the reasons we use C# typically is because, dynamic aside, we like having strongly typed things. Obviously, in this movie we have a title, tagline, and released, with released being a number, the others just doing strings. And obviously you've got movie Poco in there.
Yeah.
Do you find it? I don't know. Do you find the inode useful to use, or is it something that if you're doing this in production sort of type of thing, you'd be converting it to a movie and then passing that around your code?
Yes, that's actually an interesting part of the discussion, because in that intermediate application that simply displayed the list of movies, I'm just displaying the properties directly out of the inode. Part of it is so I gravitate towards the inode because it's just a simple data structure, right? It essentially has three elements: the ID, the list of labels, and then the dictionary of properties. And there's something compellingly simple about doing that way. When I got a little more elaborate in the final version of the application, where I'm editing and adding and stuff, I found I did need to pass a POCO around. So there's I'm probably about 75% POCO based in the final application. It all depends on the different interfaces that your services have, and the way that you can pass objects around in BLAZOR. For example, the BLAZOR data binding wants to bind to a POCO, so that's what I guess initially caused me to create a POCO, because I needed BLAZOR to be able to bind to it in that edit pop-up. I guess the one thing, and there's maybe a better answer than I was able to find, it wasn't obvious with the API that I'm using in the driver how to automatically get the inodes that are returned to be coerced into a POCO object of my design. There's different sort of ad hoc solutions, like serializing to JavaScript and then deserializing into your POCO, and I wasn't going to go there, although that seemed to be a workable workaround.
There's a nefj.driver.extensions which has a two object extension on an inode which will do that. That's just a reflection over the top of it and pushes it through. So is there anything in the app as well which cover things like relationships? So obviously nodes is a lot of what we do, but certainly the movie relationship. So when you're creating a node between when we add a movie in there, you're also adding in, typically you'll add in an actor and which roles they are taking part in. Is it basically following the same structure? So we do exactly the same sort of code base?
Right, so I didn't show relationships in this last demo because in that simple kind of tabular display of the movies, there's kind of this UI conundrum. How do you display or show relationships in kind of a traditional non-graphical web application? So I didn't approach that in this particular demo. I have another sample where I took a data set that represented all the states in the United States and which states were adjacent to which other states. So I have a different set of methods for supporting that. But that's basically a data loading operation. So I'm kind of walking around your question a little bit. but it would be a natural extension of the same CRUD methods I have, where you'd be passing a source ID and a target ID, and then providing a type, and then again a dictionary of metadata would be the pattern that I would use there.
So we've got a question that's come in. So it's probably a bit more of a generic question, but equally valid. So one question that's come in is why have you picked Neo4j for the backend database for your movie app?
It was kind of the other way around. I wanted to create a C# stack for working with Neo4j. And the one data model, it's like the Northwind data model for SQL. The Northwind data model for SQL in Neo4j is the movies database. You may think it's just tabular data, it could go in SQL, but I used it just because it's a standard database, a standard graph database that people are familiar with in the Neo4j community. So that's I think the real answer there. In general, where would you use a graph database? It's anywhere where you have relationships. Like if you think of all those servers and network hubs and routers and et cetera, like in a data center environment, being able to represent that as strongly typed, not strongly typed isn't the right word, but information-rich nodes, and then having information-rich relationships connecting each of those nodes. That's of course where a graph database is just significantly superior to anything you can do in SQL, that you can easily do in SQL.
Yeah, and I guess sort of coming on from that, because I know this is a question that Hemakan asked, where and the movie database, as you say, Michael, that's available actually everywhere. That is like the Northwind of Neo4j,
yeah.
And whenever you start Neo4j browser, you will have that option to create the movie graph, and you have a really great example in there where Neo4j sort of rules supreme, and it's the Kevin Bacon number, and it's the idea that you can go off and do shortest path between two nodes, and that's quite a painful experience to think about what kind of query and what kind of manipulation you'd need to do with your tabular data. So if with the SQL query to be able to do that. And
right.
That's sort of like the outside, and then it's the actual how the data's been laid out, like you say, because of how connections are treated as first-class citizens. It makes answering that kind of problem, that connectedness type of problem, a better fit for a graph database.
Right. Can they see my screen now or not?
Oh, one moment. Let me switch over.
So just because some people have been asking about the movie, like this is, I've opened the Neo4j browser, and I'm looking at the Neo4j database, and I've clicked on the little tab here that allows me to see the types of entities that I have in the database and the types of relationships that are there. So whenever you click on these, you get it runs a query and gives you like the top 25 or the first 25 items there. So here you can see movies, here you can see different people. Some of them are actors, some of them are producers. You can see all of these different kinds of roles, acted in, directed, etc. Yeah, so just whenever you're fooling around, this is one that's built into the tutorial that opens up as soon as you get into Neo4j. You can play the guide. It tells you how to go and create the database. There's little videos. So it's just a great way to get started without having to create your own data.
Brilliant. Thank you very much for that. So I guess maybe a last question before we wrap up this session, as we're coming to the top of the hour. So what are the next steps? What do you see coming up next for the C# Superstack?
Well, as Chris alluded to, support relationships is like mandatory. There's no point in doing this unless you support relationships. So that actually the very first thing is figuring out what that bug is and fixing that, and then getting support for relationships built into the Superstack.
That'd be brilliant. No, that's super. Thank you very much. Again, thank you once again, Michael, for joining us. That was a brilliant talk. It was really interesting. Really excited to see where this goes. So thank you once again for joining. Thank you very much, Chris, for joining us. Thank you for being a wonderful, wonderful co-host. And thank you.
You're welcome, Lou.
Oh, thank you. And thank you, everybody, for joining us on this stream. So for those of you who are catching up, if you've got any questions, the best way to get in contact with you, Michael, would be...
They can email me, mwherman@parallelspace.net. It's on the slides. If you go to GitHub, you can find the slides and find my information there.
Fantastic. So we'll make sure that we'll have the relevant links in the description to the video when we are up on YouTube. So thank you very much once again to everybody. I hope you all have a wonderful day. Don't forget, we are back next week with another Nodes 2020 extended session. If you'd like to see the schedule and the lineup, you can see that at neo4j.com/developer/online-meetup. Again, that link will be in the description. Thank you very much, everybody. Take care and goodbye.
Bye-bye.